Today I'm going to explain you how can we solve this problem from Leetcode's May challenge. The problem statement says we are given a matrix of m cross n size and each cell can have either 0 or 1. What we need to return is how many squares submatrix we can form where all the elements in this square submatrix will be 1. For example, in this particular case we have as you can see I have drawn as well. So here we can see there will be total number of 10 such submatrix of size 1, like 1 2 3 4 5 6 7 8 9 10. Yeah, so at least 10 matrix 10 squares of size 1. Then we have certain number of squares of size 2 as well, like for example this one, for example this one here, and this one here, and then this one here, 3 and 4. We have 4 matrix of size 3, size 2, and then we have the largest one that is of size 3. So overall we have 10 plus 4 plus 1 15 matrix where all the elements are filled as 1. So the filled squares here are representing cell with 1 value and the empty ones are representing the cell with 0 value. Let's take another example. So in this case, as we can see that we can always form square of size 1 with each cell with 1 value. So we have around overall 1 2 3 4 5 6 such cells, so we can already form squares of size 1 with these cells, and then we can form a square of size 2 which we can form only once. So here the answer would be 6 plus 1 7. In this case we can see total number of cells, total number of filled cells are 1 2 3 3 6 9 to 11 3 14 3 17 such cells with value 1. So we can form at least 17 squares of size 1. Then let's see how much we can form with the size 2. We can form a square here, and then we can form a square here as well, and we can form a square of size 2 here as well, and we cannot form any other square of size 2 in this. So 17 plus 3 20, and we cannot form any other square with bigger size where all the cells are filled. Alright, so let's see how can we identify whether there exists a square or not. So for example, in this case, let's see if I form a rectangle here, and then if let's say we have certain cells which are filled with 1, and we have certain filled here as well, and let's say here as well. So we know that all these three squares are already all these 3 cells are already squares of size 1, but to get another square of size 2 we need to ensure that there is one element here as well which has value 1 cell here as well which has value 1. So if this particular cell I comma j has a value 1, then we can form a square ending at this particular position. But what's the condition? Let's see, for example, we have a square here, and we have a empty filled cell here as well. So can this form a two size square? No, because we don't have these two fields completely filled with 1. So to have a square ending at this position, what we need to ensure all its adjacent cells are also filled with 1. Then only we will be able to form a square here. So if we know that there is one cell which is filled with 1, then only we can form a square ending at this position, otherwise we can never form. So for example, if there is this cell ending at this position, we can only form if its adjacent elements are also filled with 1. Yeah, now we figured out how we can form a rectangle at ending at a given point, let's say for example here, uh, how can we find what's the amount of rectangle, what's the amount of squares that can end at this particular position which has all its cell filled with 1. So let's see this example. In this case, we can see the squares ending at this position is 1, and there is one more which is of size 2. So basically, if the size, this particular cell, if we are able to get what's the biggest size of square that we can form, or which has all the elements filled with, that will be the total amount of such squares where all the elements are filled with 1. Let's say for example, if we had if we had a size of square 3 here, in that case we would have also we would have formed one more square of size 3, and there is no other square that we can form ending at this particular cell, that is on the, let's say, 0 1 2 2 comma 2. So to get the amount of square, what we need to find is what's the maximum size of square submatrix we can form which has all the elements filled with 1. So as we discussed that, to find what's the total amount of squares having all the cells filled as 1 and ending at a particular cell I comma j is equivalent to find the maximum size of such square which can be formed ending at this particular cell I comma j with all the cells within the square filled with 1. So what we can do, we can try to find this particular answer, and then we can add up for all I comma j while running two for loops. I have taken this area out of this big rectangle to understand how can we find the number of square that we can form at a particular I comma j cell. So let's see. So if all of these cells were filled with value 1, we can always form a square of size 1 at ending at each of these cells. But to find a rectangle ending at the biggest rectangle that can be formed ending at a particular cell depends on the biggest rectangle that we can form on the left and the top right, and also on the diagonally adjacent cells. So in this example, as you can see, the largest rectangle that can be formed at these 3 points, there is this and this, is equal to 1. So the largest amount of the biggest rectangle or the biggest square that we can form here at this middle cell is going to be minimum of these values plus 1. And so we can change this one to, let me just change it. Alright, so this should be changed to 2 because the largest rectangle that can be formed ending at this particular position is the minimum of these values plus 1. So similarly here, and ending at this position, what's the minimum amount of the minimum size of square that can be formed from these 3. So here we can see that in this one it is 1, in this one it is 1, and this one it is 2. So the maximum size that we can form at this this cell ending at this cell is going to be changed to. And as a similar reason in here as well, in this cell we can change it to 2. Let's change this one, and this should be changed to value 2. Now for the last cell, as you can see, the minimum of these 3 cells is 2, so this can be changed to 2 plus 1, that is 3. So this is how we can calculate the maximum size of square that can be formed ending at each particular cell. So if you compare this with this cell, it shows the correct result, that we can form the biggest size ending at this particular position to be equals to 3. So now this is similar to what's the amount of squares that we can find. We can use the same approach to find for all these cells, and then in the end we can add them up. See how we can generalize our approach into some sort of recurrence relation or some sort of formula using which we can find for a particular cell what's the amount of squares with all the cells 1 ending at that particular cell. So to find this number for any cell I comma j, we have seen that it should be 1 plus minimum of diagonally adjacent cell and left and top cells. So minimum of these cells plus 1 if this particular cell contains a value 1, otherwise it will be 0. So we should run this for all the cell containing for all the cells within the given matrix, and then we can add this f of ij for each of them to find the total number of such squares. So I hope I was able to make it clear to you guys. If you have any doubt or any comments, please let me know in the comment section below. Also, I have added the code for the solution for the problem in the Leetcode into my description. You can see there. Alright, so thanks for watching this video, guys.